is, it is. All right. It is go time. Let me just change my settings here for a second. All right. Almost said good morning. Good afternoon, everybody. Welcome to the last week. See, you're getting so used to it. I don't even ask, and you already tell me what I want to know. Perfect. All right. So, we are maybe just giving another minute for everyone to get in and get ready, since I'm not seeing any questions yet. So in the meantime, I'll be right back. All right. Is everyone excited about the last week? Ooh. Now I realized that my answer key that I used to grade was not the one I really wanted to share, but I never got around to writing a more detailed sort of learning one. I will quickly share the one I used, but understand that your answers might not look the same as mine in terms of the work shown. So let me just quickly do that while you're getting ready as well. And you can at least compare your answer to what I have. Finding it is the pickle. Where did I put that? Wow. Where did I put that? Feel free to chat and let me know what topic you want to discuss first as I'm trying to find this. Keeping in mind that this is your last week. So if you're not taking the chance to say something, you're gonna miss it. Let me quickly drag this to our course chat and then you're ready to go. Nine, come on, SU quiz 1 and 2 answers. Okay, that should be in your course chat, and we are ready to. We got some questions here. Perfect. Okay, let's do it. Many people answered Charles for the K question. You are not alone, and you are also correct. It totally was Charles. So, can we go over questions 12.2, specifically questions similar to 12.2 number 7? Okay, so in Chapter 12, there's some stuff, but there's mainly two things that we are paying attention to, and that is the number line model and how to explain that. We're now going very way back to basics. How do I teach little Timmy to walk on the number line and do arithmetic? And the alternative is the chip model, which in some cases people think it's more intuitive, but as soon as I get to negative integers, it's questionable if it's actually better. It's just an alternative. So we want to do 12.2, specifically similar to number 7. And also question 12.3, specifically number 5. Number 5. So let me just quickly say, in 12.3, we get a little too fancy, and I need to correct that. Any of these double negatives, just ignore those. I'm never going to give you that, since it's just a little too far. We have either a positive integer or a negative integer in each case. We either have addition or subtraction in each case. None of this. So in problem 12.3, number 2, 3, 5, either ignore it or get rid of that extra negative in front of the bracket. That's just silly. In hindsight, they're not really in line with what we want to ask here. So it's going to be two integers added or subtracted. That is it. So let me get my app for drawing and writing and some answers. I'm obviously super prepared. And then we will walk through a 12.2 number 7 style question where I have two negative integers and I have a minus. And we'll look at both the number line and the chip model. I also said that because it was over a weekend that you may have the opportunity to look at fractions, so we can definitely start that conversation as well. Okay, let's do it. So let's just make an example here. We don't have to make anything we already see. We could just make like a -3. Now in line with what many books do is to emphasize the difference between a negative sign and a minus that we call a mathematical operation. Those two are not the same. So I put the negative a little higher, and then should we start with that? Yeah, why not? Minus. And then let's just do like a 4. Actually, let's make it less. Let's do a 2. So I have a negative integer and I have a positive integer. You can use brackets just to emphasize what is the number name and what is the arithmetic to combine these. Okay. So I have my number line. It extends in both directions. Now, in the beginning, little Timmy's always going to mark numbers starting at 0, but soon you will realize you can just start wherever that first number is. And I'll list some numbers around that starting point. So it's a 3-step process. Let me just check if anyone. So first number is where we start. There I am. It's obviously me. I look exactly like this. Then I look at the operation, which is subtraction, which means in general, I look to make less. In general, my intuitive understanding of subtraction, which means I am going to look in the negative direction. Then I see what I'm supposed to subtract, and it's the positive integer 2. I then walk 2 steps in the direction I'm looking, and there is my answer. Negative, whoa, that was supposed to be a 5. I wanted to not make it curvy. Negative 5. Now the absolute, well, in this case it doesn't matter. Next time I'll say something. Okay. So we have 3 things we need to indicate. Starting position, coming from the first number. Operation, telling me which way to look. Many people, when they answer this in the test, they don't show which way they look. That's a part of this method, this procedure, and I have to take something away. It's a key step that you have to show. And then depending on that second number, we step. Okay, so this is number line. Now I'm going to keep this one the same and then do the chip model for negative 3 minus 2 as well. Feel free to interrupt if you're not sure. Chip model. Well, I need a key. My key can, well, hold on. I am on speaker instead of my headset. Hold on here. Why is that the case? Need to go change my settings apparently. Okay, go.
So when they indicate the directions, can you just do like the arrows, like the left or right like that, or do we have to like draw?
Yeah, you just have to indicate which way the little guy is looking.
Okay.
Whether you do that with an arrow or little beams shooting out of his eyes, it doesn't matter to me. But there has to be some indication of looking that is separate from stepping.
Okay, thank you.
Absolutely. Okay, let's see if we can keep both in the same screen. Sure, why not? They've got very little to do with each other, but so let's get some color in here. Why not? Let's make blue circles positive. Let me color it in as well. And then I guess red circles. Red's usually bad. Danger, bad, negative, all those things. So then let me write here, this is positive and this is negative. All right, so now my first number is what I start with, which is negative 3. So I start with 3 negative chips. 3 negative chips. There they are. There they are. There they are. Starting point. Start. Then I need to take away, minus tells me to take away. What do I take away? I take away 2 positive chips. This is positive 2. But I see no positive chips to physically remove. So I need to adjust the chips that I see while not changing the net amount that I have, or the net value that I have. I can do that by introducing a positive negative pair. So we could say here I have a positive chip and I have to include with it a negative chip. I should have colored it in. And by doing that, I'm not changing my net value of chips. It's still 3 because the blue and the red cancel each other. And then I should do that again because I need to see 2 positive chips on my table, because that's what I want to remove. So I bring in, I don't want to say add, I bring in another pair. So let me write this down here. So here I bring this in, bring it to the table. So now I have all of this. Now I can follow the procedure of taking away, take away the two positive chips. They are gone, they are gone. And then what I have left are obviously the 5 negative chips. 1, 2, 3, 4, 5. Color, 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 color. And therefore my answer is -5, as we all of course know. Squeeze it in. Got a little messy there, but you get the idea. Show some work. Show some things happening. The question specifically is going to say demonstrate, explain, use the chip model or the number line model to show how you get this answer. Everyone knows it's -5. That's not the challenge. How do you explain at the base level how this gets us to -5? So you need to show some sort of explanation to convince me that you understand the chip model, not how to get the answer. We of course have more sophisticated ways of doing that. We are thinking at the bottom level. Okay, so now let us make that second number a negative number. What should we do with the first number? Let's make it negative as well. You have to run through all the possibilities. Let's take, let's say -3 minus -2. See how my minus sign and my negative sign are not the same? Very important. Now, of course, we have more knowledge than little starting out Timmy. We know that there are mathematical properties telling me that subtracting a negative integer is equivalent to adding the positive version of that second integer, and so on and so on. That is not what's happening here. I am not to simplify this, then find the answer. I have to use this as it is presented. You simplify this first and say -3 plus 2, 0, because that's not the question. Little Timmy has no knowledge about these shortcuts that we may have. That was supposed to be a straight line. Okay, so we have our number line. Let's go here, -3. Let's put that over there. Let's put -2 over there, -1. I'm of course cheating because I know which direction I'm going to go, but Timmy might not. Okay, first number is where I start. There I am. Next, I look at subtraction, meaning I'm going to look to the left, the negative side. Then, if this was a +2, the second number, I would walk forward, but it's a -2, so I do the opposite, which is stepping backwards from where I look, and my answer is -1. And we, of course, knew the answer was -1. The issue is, how does the number line model get me to that answer? Chip model, -3 minus -2. It's very quiet. It's making me nervous. No one is saying anything. Means super simple, stating the obvious, or no idea what's happening.
I understand like the number line, but like I found the chip model was the one that I would get confused with, like the extra negatives and stuff.
Absolutely. People tend to think, why can I not change colors? People tend to think, oh yeah, chip models. Oh, kids can move chips and count them so much better. It depends on your numbers. In the case of negative integers, I feel it's way less intuitive. Absolutely. But until I have sort of looked at this and thought about this, I could very easily, let's suppose I'm teaching whatever the grade is, negative integers for the first time, and I want to give them an intuitive feel for what these numbers are and what they can represent physically. So I then think, oh, chip model, absolutely. That has a more tangible physical um, idea behind it. And then I go to the classroom and I very quickly realize, oh wait, this how do I talk about negative integers and subtraction? I didn't think about this. It's not as straightforward as one might think. So I need to be prepared and at least know if I don't like it, I'm going to avoid that. Maybe the number line model is sufficient, which in my opinion it is. But some people love these chips. It's not necessarily the greatest thing ever. I have to know what I'm doing with them. If I'm going to use them right. So I still have 3 negative chips. That doesn't change. 1, 2, 3 negative chips. I mean, my kids I never taught them the chip model. It depends, right? I tried the number line model first. They were fine with it, and then there's absolute no reason to switch. But I guess some people might find the number line model a little bit more abstract because I'm not counting things the way I'm counting steps. I don't know. I feel the number line model is perfect. Anyway, I'm looking to take away, and I'm looking to take away, actually let me write here, take away, stay, I can't get it to stay. Oh, I'm in black. Okay, never mind. I'm taking away because that's the intuitive concept of subtraction. What am I taking away? I'm taking away 2 negative chips. No problem. I can see 2 negative chips right there. Be gone. And I have left 1 negative chips. Why is it so small now? Man, is this Monday? Yeah, it's a Monday. You can tell. I cannot stop it. Oh, there we go. My pen is back. I have 1 negative chip. Thank goodness. So -1. So it really depends. The chip model is super simple and a good go-to in the cases where I see what the instructions want me to see. In this case, the instructions tell me take away 2 negative chips. Fine, I see them, no problem. Physically remove them, great. In other situations, the instructions tell me to remove something that's not there. That's where the intuitive side of the chip model fails a little bit. That I have to be okay with this positive negative cancellation, altering the look so that I have what I should physically remove. That's where people get a little uncomfortable. So it just depends. It depends on the numbers involved. It depends on the operation. It depends. Pros and cons to both. I definitely need to know both. I don't need to like both. I might want to avoid one at all costs, but at least I know why. At least I know why. Mod art, no, that is just for fun. That is just for fun. For the in-class course, sometimes I use that as an extra assignment, but we are not going to do that. It's too hard to really do when we're not together in person at some point. So you can completely ignore the mod art if you want. So for chapter 12, we're looking at the 2 problems. It says use and explain the number line model. Use and explain the chip model. feel free to leave out 12.3, 12.1, 12.2, cover that page perfectly. What is next here? Where is the next modular arithmetic? Now there's a lot of words in that chapter to try and explain things. We're not going to go crazy with it. We just want the idea. We want the idea. We're not going to go over more of 12.2, but I can make some more examples if you want to. I'm not going to do specific problems. Then I'm doing your problems for you. More the idea, and then you have more to try on your own. Let me just check the questions here. For chapter 13, 13.2, 13.3, 13.3. Okay, where are those things? 13.2, 13.3, 13.2, 13.3. Where are you? Okay, so first of all, we need to be able to do a calculation mod something. Okay, we're not doing division because that's a little tricky. That seems to be the theme. Division is always the odd one out for our purposes, or is handled separately by divisibility concepts. Then we have 13.2, the concept of the additive inverse. And I don't really care too much about 13.3, but we could connect it. Yeah, we could connect it. I just want to do 1 and 2 first. So basic calculation and additive inverse. Okay, let's do that. There are 3 types of questions, yes. Some more important than others. Just realized my mic wasn't even next to my mouth. So I might have been a little quiet. Okay, so we want to have some basic arithmetic. If I say 6 plus 7 mod 3, then I could still do this as 13, and then that is equivalent to 13 steps on a circle, but the circle only has 3 places to stand. So I go around and around and around. Every multiple of 3 will put me back at 0, and therefore I will go and take 12 steps, and that will still put me at 0. So it's 1 mod 3. Now you can see it like that. You can see it as the remainder after I divide by 3. They're all the same. The point that is what happens when I am walking on a circle. So to a large degree, we're still thinking of the number line model, definitely not the chip model, number line model. As I'm doing this basic arithmetic, I'm just not walking in a line, I'm looping back on myself when I walk on a circle. That's really about it. We can do a subtraction. If we say, let's say 6 minus 8, and I want to work mod 4, I can still think of that as negative 2. What does negative 2 mean? Oof, that is an ugly circle.
It means 0?
It depends on the circle, right? Depends on the circle. In this case, I have a mod 4 circle, so 0, 1, 2, and 3 are my only possibilities where I can stand. If I were to walk on a number line, let's just take this number line, negative 2 on its own means what? It means I stand right there. I stand 2 steps left of 0, smaller than 0, in the smaller direction. So even though I have a number on its own, I can see that as 0 plus step, maybe not, yeah, plus. Or I can see it as 0, I don't know if I want to. Yeah, I'll just take 2 steps back. That's sufficient. Don't want to get ahead of myself here. And that's going to be putting me at negative 2. So if my starting point is 0, the procedure is, I can see a procedure as the same as just a number. So that means on the circle, -2 is the position when I stand at 0. There I am. And I am looking forward, taking 2 steps back. That's going to put me over there. And that is therefore equivalent to 2 mod 4. I do the same thing as what the -2 tells me to do on the more intuitive number line. Walk 2 steps to the left. Either looking to the right and stepping, or do whatever you want. Move 2 steps to the left, 2 units to the left. But on the circle, there it loops me back, and I'm sort of counting down to a position that is actually a number higher than my 0 because of the loop effect. So in both cases, even in multiplication, I do the arithmetic as if it's the number line. But the number line has a section here. Well, it's really over here, right? This section over here just repeats itself over and over and over infinitely many times. It sort of folds in on itself. And my only eventual answers when I'm working on a circle are one of these numbers. So I just have to figure out, I can think of the number line in terms of what -2 tells, where -2 tells me to stand, 2 positions left of 0. So then on the circle, I just go 2 positions left of 0. That might be the simplest way to do it. Of course, there are shortcuts, but I don't know if they're really beneficial to us at this point. Any questions, at least how to take my number line answer to the corresponding answer on the circle? I think that's the first key thing, that things are similar, but also not the same. So I go to what's familiar, number line arithmetic. I just have to transfer that answer to one of the options I have on the circle. How do we feel about that?
Bigger one?
Sorry, I only got the last bit of your question.
Oh, sorry. Can we do a bigger one that's like a mod 12?
Sure.
With a negative number? Because I don't really understand why he's looking right.
I mean, I could see this in 2 ways, right? I can get to -2 in 2 ways. I can add, starting at 0, I can add -2, or I could subtract 2. In both cases, my answer is -2, right? You can do either one of these. Either way, my end position that -2 tells me to be at is 2 units left of 0. How much detail I think of in the number line model doesn't actually matter. So whether you look right and step back or look left and step forward, the eventual and the destination's the same.
The direction you're looking and the direction you're going are opposite.
No, it depends on the operation. If I strictly follow the number line model in these 2 in the box here, the first one's procedure is very different from the second one's procedure. Addition is technically not the same as subtraction, yet their end answers might be the same. There's always a subtraction sentence always has an addition sentence that gives me the same answer. So I have to decide beforehand, which one am I looking at? I can't look at both at the same time. The number line model in its basic pure form handles this very differently. It says if I have 3 things. I have the first number, I have the operation, I have the second number. The number line model says stand at the first number, look according to the operation, move according to the second number. And if those things aren't the same, I'm going to look and move differently. In the first one, I'm standing at 0, first number. I'm looking according to addition, which means I'm looking to the right. I'm stepping back because my second number is -2. And I end at -2. In the second one, my number line model says stand at the first number, 0. Look according to the operation, which is minus, so I'm looking left. Step according to the second number, which is a +2, so I'm stepping forward, which of course gets me to -2 as well. There's always two versions of this, leading us to eventually the shortcut, if you will, that a positive and a negative is a negative. Though that's a very simplistic way of saying it, but it works, so we can get away with it. But it's because that there are always two versions. Given the same first number, what did I just do? Given the same first number, there's always two ways of getting to the same answer. By simultaneously altering the operation and the second number in a specific way, I can get to the same result. Because the operation tells me to look, the second number tells me to step. So as long as I change both, I'll still essentially move to the correct position. So when I am trying to imagine what is -2 telling me, if I can always start at 0, and I can see -2 in two ways. Either in an addition way, where I'm going to have to step backwards, or in a subtraction way, where I can step forward. But the operation and the second number together will get me to the destination. Now, you could think of either one of those. It doesn't matter. I just happen to think of the first one. Either way, I move 2 units left of 0. Doesn't even matter how. I could magically teleport there. -2 still tells me to get there. Nothing has changed when I'm on a circle. Think of teleporting if you don't want to think of the number line. I have to teleport or get 2 units left of 0. Now, what's left? Left is going to be that direction, because increasing is the right direction, the clockwise direction. Left is going to be counterclockwise. So then I take 2 steps, and the number here that's equivalent to -2 on the mod 4 circle is 2. And I can only have an answer that's one of these numbers. Each of these positions, each one has infinitely many equivalent positions on the number line. For example, seriously, stop. There we go. For example, this bottom position of 2 on the mod 4 circle is equivalent on the number line to -2. It's equivalent to 6. It's equivalent to 10. It's equivalent to -6. Is that right? No, yeah, -6. Because as soon as I make a loop of 4 on the number line, I've traveled 4 steps in either direction. So every fourth position on the number line, when I have this looping onto itself property, they're all the same position. They're different on the number line, but not in the circle. So they're all represented by this 2. It's representing all of these numbers. They're all equivalent in this arithmetic. Now, if my answer is a -2, another way of then seeing it is, okay, currently I know I'm somewhere, happens to be this position, but the way I'm referring to this position is not quite correct. Negative 2 isn't the ideal name for this position. I could just think of taking 4 steps around clockwise, adding 4 to this, and my position does not change. Any 4 steps, any way, my position has not changed. I'm just altering the representative of that position. And I want this one in the circle, so I could also take that and just add 4 to get to 2. But I prefer a more intuitive walking around strategy, but it's the same. If we take, for example, something bigger, you said, it doesn't change anything. Um, let's do a multiplication maybe. I don't know. 7 times 5 mod. Sure, 12. Why not? I do it just like I would normally. It's 35. I can write 35 because it is 35. But that 35 on the mod 12 circle has a specific representative. What is that representative? Well, I can think of how many 12s how many loops, how many full loops can I get into 35 steps? Yeah, I can only do 2, right? I can't quite finish that last one. That uses 24, and I have 11 left. And so the answer is 11. I know where I'm going to be. I'm going to be 1 step before 0, because that would be a full 36 steps would get me to 0, which would put me up here. Just 1 step before that, and its representative is 11. So what makes this perhaps complicated is that there are different ways of looking at this. There are more efficient shortcut ways, but if I'm not ready for those, then my understanding suffers a lot, which is why I'd like to take a slower walking around the number line, just in circle form. An approach like that, which promotes understanding. It's not going to be fast, but I don't need to be fast. I need to rather understand what this circle is asking me to do. How is it similar to a number line? How is it different? Yes. Okay. So what have I missed here? So 13.2 is not yet done. We've done 13.1 style questions. Okay. So what do we do with an additive inverse concept? And again, I want to build on something that I am more comfortable with so that this isn't as strange. And for that, I'm going to go to my number line. So let's just take something simple. Let's focus on a 3. Okay, so let's think of the relationship between 3 and negative 3. It's not random. It's not like I'm saying the relationship between 3 and negative 7. They don't have as close a relationship as these two do. That if I fold it on 0, half of my number line onto the other half, they lie on top of each other. Another way of saying that is negative 3 plus 3 will give me 0, one way or the other. Together, they give me 0. They cancel each other. And the mathematical word for canceling or things that cancel each other is inverse most of the time. But I have other operations, like I have multiplication and all kinds of stuff. So I kind of need to say additive inverse so that anyone who reads the term knows, okay, it's when I add, these cancel each other. Because when I multiply, other things cancel other things, and it's not the same pair, negative 3 and 3. So I do need to specify what's the operation in which these two are inverses. added in the addition sense, they cancel each other. So now what does that mean? I can look at this one of two ways. One way, the super intuitive walking around on the number line, is if I took, let's look at this first one. If I'm at -3, meaning I moved back, boop, 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 and now I'm over here. I'm at -3, which requires me to, regardless how, teleport from 0 to that position, 3 steps to the left. I'm at a position. What would it take to get me back to 0? I would have to do the opposite. I would have to take 3 steps back, 3 steps in the positive direction, which is +3. And I can also say, if I'm at 3, what would I have to do to get to 0? Now, I don't have a looping option in this case, so I'm going to have to move towards 0 in the only direction I can, which then means -3, 3 to the left. But in the case of a circle, it's different. First of all, I need to know what the size of the circle is. Now let's not get too crazy. Let's make it I don't know. Maybe an even number is nice. Let's stick to 12. Let's stick to 12. Why not? It's an easy one to draw. I picture a clock. It's not hard to draw, and it's not hard to space them out nicely. So why not? So now if I need to specify the circle, of course, because different circle, different thing. So I'm working mod 12. Okay, now I know my size of my circle. If I now say, what is the additive inverse of 3? It means the same thing. I'm just, my number line model, my arithmetic, my counting model is now on a circle instead of a straight line. But it means the same thing. If I'm at 3, because that's the given number, how do I get back to 0? Yes, you could still say, oh, additive inverse -3. Yeah, it's -3. Sorry, that looks like a 3 as well. The answer is certainly -3. However, that's not one of the numbers, mod 12. So that's not a very good answer. I need the equivalent representative on the circle. -3 isn't one of the labels on my circle. It's not wrong. It had a label right there on the number line. It was a unique position, had a unique label, but not on the circle. So that's not really a sufficient answer. I need to just convert this to the appropriate number, which is going to be 9. That's one way of doing it. 9 because I just add 12, right? Any full loop. So actually there's the -3 actually sits right there behind the 9. 9 is just a representative. The other way of doing it is to say, okay, you want the additive inverse of 3. That means I'm on 3 and I'm looking for the number of steps to get me back to 0. I can't go back because there's no negative concept here technically. So I'm going to keep going forward. 1, 2, 3, 4, 5, 6, 7, 8, 9 steps. And I get my 9 again without the thinking of a -3. They're both correct. They're both going to get me to 9. It's just whatever feels most intuitive and promotes understanding to you. Additive inverse. It's very quiet. I am not loving the silence. It's making me uncomfortable. Does any of this make sense? I don't
Can we
know.
go over another example? I'm still sort of confused.
Sure. You pick the size of the circle, but let it be something I can actually draw.
We could do 8, I guess.
Let me try 8, sure. 8. 8 is gonna go 8 numbers on the circle. Why should... Oh, it's sideways now, isn't it? I could do it this way. If I turn my head, that's 4 already. They're not going to be perfectly spaced, but that's 8, isn't it? They are not perfectly spaced. Whatever, doesn't actually matter. Doesn't actually matter, right? I could have done a much better job of this. Why did I turn my head? Oh well, doesn't matter. Mod 8. And pick a number. Not 0. 0 is boring. So we're looking for the additive inverse of something.
Five.
Sorry, say again?
2.
I'm going to pretend you said 2, but I couldn't quite hear
Okay.
it. Doesn't actually matter, right? So I find the most intuitive option the walking one, and it's perfectly sufficient for us. Let me think, is that sufficient for us? Yeah, I don't think that's ever going to get us into trouble. Yeah. So additive inverse of 2 means I'm at 2. What should I do? Right, I'm looking for something that gets me to 0 when I'm working on the circle. So that means I'm at 2. Adding means keep walking in the positive direction. 1, 2, 3, 4, 5, 6 steps. That guy is a 6, and therefore the additive inverse is 6.
Steven, don't you just always take the mod and then subtract the number that you're working with, and that will give
I don't
you...
want to. You certainly can, but I feel I'm losing a little intuition that some people might need.
Okay.
But you certainly can. And if you see that, like, I can just do this. What is he talking about? Absolutely, go for it.
Okay.
I'm trying to guess what people need, right? And it's really hard. It helps when I see like confused faces. I say something, I see some confused faces, I change it. Right now, I see no faces, so I'm totally guessing.
Thank you.
You should make like some confused faces. Let's see, can we do that? Like this one maybe. That then I should alter what I say. So feel free. This one, mildly concerned, but it's not that bad. I could probably work with it. But I see no one's faces, so it's totally up to you to let me know. But no, there are many shortcuts and mathematical properties hiding behind these things, making this actually super efficient. But if I'm not ready for it, I won't really understand by doing that. So walking around the circle is sufficient for our level, right? We're not trying to get to be fancy. The key thing here is that there's a lot of similarity between this and the number line. I just don't have negative integers here. They're hiding behind these representative numbers. Of course, the additive inverse of 2 is negative 2. But there is no, what's the representative for negative 2? You could then also say this is equivalent to negative 2 on mod 8. What is negative 2? It's 2 steps to the negative direction. So, whoops, that was an ugly circle. So 6. So you can argue both ways. It's all going to get you to 6. And that means that 2 plus 6 is 0 mod 8, of course. And 6 plus 2 is 0 mod 8, because they add up to 8, and loops of 8 gets me back to 0. All right. So now, let's think, what is the simplest way for the next kind of question? If we look at the number line, do we have a number line?
I'm sort of confused why it's 0 mod 8. Like, what was the point of like finding the 6? I guess I don't know.
The additive inverse is just a fancy word for saying what is the number that is canceling the effect of 2 on this circle. If I've taken 2 steps, I'm at position 2. I'm standing on the circle. What do I need to do to get back to 0? I need to take 6 steps. So it just has a fancy name that's called the inverse. What do I need to do to cancel my position? That's all it is. There's nothing else. It sounds so fancy, so you think, oh, I need to do something more here. No, it's just what is canceling the given number. And canceling, we mean getting me back to 0, which is nothing. That is literally all we're doing.
Okay,
2 means I've taken 2 steps. What do I need to do to cancel that effect? Take 6 more steps and I'm back at 0.
so the answer will always be 0 mod something. It's just finding like what
No, that's
gets
not
you
the
to 0.
answer. We're looking for the additive inverse of a number. That number, when combined with the given number, gives me 0 because they cancel each other. The answer is, what is the other mystery number to get me to 0? The answer isn't 0. The answer is the question mark.
Okay, yeah, but I'm just saying though, like it'll always be
Oh, yeah,
like it
yeah.
should
Always
equal
0.
0
Yes,
mod
yes, yes.
8. Okay.
Absolutely. Because that in the addition sense, 0 is nothing. You've added you give me 0 money, you've done nothing.
Okay.
I've traveled 0 miles, I've traveled nothing. So it cancels. It's the representation of nothing in this sense.
Okay.
And it then of course depends on the circle, how many steps I need to take to get back, of course. So you could think of the 2 and the 6 together, they need to give me 8, which is equivalent to 0. There's an 8 hiding right there. Whoa, what did I just do? Seriously, what did I just do? There. There's an 8 hiding right there. 8 and 0 are equivalent on the mod 8 circle. So the size of the modulus is the same as my target. These two numbers have to add up to that. So if, for example, if I stick to mod 8 and I say the additive inverse of 5, and then you say additive inverse of 5 mod 8. Let's write it down. Additive inverse of 5 mod 8. I'm looking for a number on the circle, same circle, after I'm at 5 to get me back to 0, which is the same as intuitively saying, how many steps do I need to keep going to get to 0? 1, 2, 3 steps. 3 steps. Because every 8 steps gets me back to 0. You've taken 5, you need to just take 3 more, and you're at 0. So the number of steps that will cancel where you're at, 5, is 3. How do we feel about this?
Okay, that makes more sense.
So I want to break it down to just walking and positions and have it as intuitive as possible. Are there shortcuts? Of course, there are many, but they don't promote understanding, which is way more important than anything else with this topic. I actually don't even care about the problem 13.3. That's where things get a little mathy. Where if we look at the number line, I'll quickly give you the idea, but I'm not going to put that on a test. number line. So if we think of the number line and I think of whatever, 3 minus -2. That's not the one I have, right? No, it's not. Okay. 3 minus -2. Number line says, okay, 0, 1, 2, 3, 4. Okay. Number line says stand at 3, subtract. So look in the making smaller direction, and then walk 2 steps back. I need a 5 there. I walk 2 steps back. 5 is my answer, which was not a mystery. I can get to 5 starting from 3 in a different way. I could also say 3 plus 2 equals 5. Those are equivalent. Given the same starting position, I can end up in the same place in 2 different ways. One was by way of subtracting a negative integer. The other one is by way of adding a positive integer. But it's not random. These two are very closely connected. If one is -2 and the other one is 2, they are not random. They're always going to be additive inverses of each other. So when we casually say, after a while doing this, we notice patterns that are true. 2 negatives make a positive. That's a very casual, informal way of saying it. Really, subtracting by a number is equivalent to adding by its additive inverse, or the other way around. Adding an integer, actually it doesn't even matter if it's an integer, adding a number is equivalent to subtracting its additive inverse. That if I flip the operation, I have to flip the number as well. Let me just check the question here. When we write the answer for the additive inverse of 5, do we just write 3 or -5 equivalent to 3? It doesn't matter. As long as you write a 3, that is what I'm looking for. For a question like that, very much you just want, if you just have the answer, it's okay. If your answer is wrong, then I would like to see something to give you part marks. But if your answer is right, 3 is all you need. So now, let's go to the mod 8 circle. I need to redeem myself, make a better circle. Let's go mod 8, 0, 4. Why can I not do mod 8? How hard is that? 3, 3. Is it just like this? Why do I want it to be more complicated? I don't know. That can't be right. Oh, I don't know what I'm thinking. I want a more complicated circle for some reason. No, that's all it is. All right. Mod 8 it is, just as an example. Now, subtracting with negative integers and all kinds of stuff like that could be a little bit more confusing, because those numbers aren't visible positions on the circle anymore like they are on the number line. So if we now say, how does the book ask it? Oh, they're all subtraction, okay. So if we now say something like 3 minus -2, I put brackets around it to emphasize what the name of the number is. This makes a little less sense. Though I could still argue the number line model. I could still argue I'm at 3. Let me stand this. No, I stand on the circle. I guess I could walk this way. I stand at 3. I subtract, which means I look to the smaller side relative to 3. I then walk. Oh, this is, yeah, it's okay, it's okay. I then walk 2 steps back. Boink, boink, done. My answer is still 5. The underlying concept of subtraction and division doesn't change. Now, understanding the relationship between addition and subtraction and additive inverses allows me to say, well, I subtract by an integer. That is the same as adding its additive inverse, which is, how should I say? I'm just trying to look for this simplest way to not make more of this when we need to. I actually don't want to do any more than this. It's exactly the same. It's exactly the same. The only thing that this problem is trying to do, now I know in the answer key it might look different, but not this version as much. We'll take something that's not quite the same as a double negative in a second, like number 2 and number 4. We'll do that in a second. Uh, if I want to rewrite the sentence from subtraction to addition or the other way around, I need to change the second number to its additive inverse. That's the key. Okay, so that's the same. Nothing has changed. If I now say, for example, 3 minus, let's go 7. 3 minus 7. And specifically, though, why would we want to do this? Just to show the link. There's no actual benefit in doing this. If I want to write this to an addition, I need to flip the second number to its additive inverse. Now that's always the standard name for the additive inverse. 7, negative 7. But negative 7, it's not here. It's not on my circle. So that is equivalent to what on the circle? Well, negative 7 is 7 steps back from 0. 1, 2, 3, 4, 5, 6, 7. It's 1. And therefore the answer is 4 mod 8. So that allows me to honestly not do much at our level. It allows me, when things get complicated, to rewrite sentences in one operation to another one by exploiting the properties of additive inverses. So it gets a little mathy, which is why I almost want to ignore this kind of question completely and just understand walking around a circle, what's different, what's the same. It's more than sufficient for us. So I'm not going to ask you a question like problem 13.3. For those that are a little bit more inquisitive mathematically, yeah, there's a lot. This opens a door that never gets closed again. But we don't need to think of all those things if we don't want to. We just want the basic idea. Problems 13.1, 13.2, more than sufficient. More than sufficient. Okay, mod art, just for interest's sake, look at the pretty patterns that we can make. It's kind of cool. And some more instructions for fancier things that you can make. Look at that. So pretty. So pretty. But that is not a test situation. Yes, okay. That was a good discussion. 13.3 will not be on the quiz now. The quiz will have questions like do a calculation, mod something, subtraction, addition, multiplication. Maybe you want to walk around the circle, maybe you just want to do it, and then reduce it to the representative number. And the other question is find the additive inverse of a number mod something, like the first 2 problems. And that will be that for that kind of question. So in terms of quiz 3, what do we have so far? We have the basic concept of divisibility, long division, quotient, remainder, divisibility tests. That's page 1. Page 2, prime numbers. Can you verify if a number is prime or not? Do you know what to test? Do you know how far to test? So on. And page 3 is, think about all these pages. There should be 5. What are we on? 2? I'm going from memory here. One page, which could be page 3, yeah. Least common multiple. Oh, sorry. Yeah, least common multiple. Greatest common factor. And factor trees. Prime factorization to get those. Page 3. Page 4 are these guys. Don't ask me what page 5 is now. I can't remember. I'm going to look at the table of contents here. It'll let me think what page 5 is. Not that it matters, really. We have divisibility tests. We have prime numbers, finding prime numbers. Then the factor trees. Oh, I'll have to get back to you on what page 5 is. That is a good question. Oh, haha, the models, right. The number line model and the chip model. I forgot those. Let's get back to start. Divisibility, page 1. Prime numbers, page 2. Factors and multiples, page 3. Number line and chip model, page 4. Modular arithmetic and inverses, page 5. So it's perfect. It's 1 page per chapter. Yeah. Just spaced out for a second. And then we get to the lovely world of fractions, which, I mean, everyone loves fractions. Like, I haven't met a person who doesn't say fractions, that's their favorite topic. So we have to include fractions, but we're going to do it in a very specific way. We are going to do it in the most basic, intuitive, understanding way where you start learning about fractions at the beginning and not take shortcuts simply to calculate an answer. We want to get a number sense for fractions. So we're going to hug that left intuitive side for as long as we can. Actually, all the time. Which is a very different goal than just calculating things with fractions as fast as possible. That's not our goal. Our goal is to understand, get a number sense for what is a fraction and what does it mean to add fractions, subtract fractions, multiply fractions, divide fractions. What does that mean? We understand it with integers. When I talk about division, when I talk about multiplication. But what does it mean for fractions? Sometimes it's the same, sometimes it's not the same. And how do I really explain that number sense? In order for me to do that, I have to understand it first. So that is going to be our goal. So we start out small with 14.1. How do we represent a fraction? You could do it with a circle, with pizza pie, slices. It's a little hard for me to draw, so I'm going to stick to my Panormous pizza rectangle, but it's the same concept. And then there's a lot of time on fraction arithmetic. Can I use those basic diagrams to explain, just like the number line and the chip model explains how to find an answer to the arithmetic question. So too do we want to have a way to find the answer to a fraction arithmetic question. How do we do that? And then there's some extra bits on what's a rational number. Can we handle decimals? Can we round decimals? Just some comfort level. That's going to be it for chapter 14. Don't worry too much. I don't know if there's a video. I don't think there's a video on 14.5. It's really just sort of an outside extra issue that do be careful keep in mind that if we're teaching these things, something that's easy to you might not be easy to teach, things like that. So it's that extra thing in the back of our mind. Oh, we have to think about teaching this. It's not just me doing it. Oh, but that's just for you. It's not test questions. It's just for you to think about. And then we cross over to algebra by way of percentages. Good times. But one thing at a time. Not everyone has necessarily looked at the fraction chapter, but I believe that is the goal for tomorrow. Then, ooh, we have very little time. Then we have Thursday, Friday. Thursday will be, I'm totally guessing, do check the website. Percentages, and then we finish algebra. So I think fractions might go tomorrow and some of Thursday because it's going to be a big one, and it's definitely the hardest of all of these. But really, however you can get through this, just don't wait for the website pacing. If you want to go faster, it's totally fine. Anything you want to talk about in our last 14 minutes? So I say here in the textbook, we are looking at the left intuitive understanding side of fractions. How do we represent a fraction? Do we understand that number sense portion of a whole? Very important. It starts like grade 2 fraction concepts start. It's early. Can't teach it if I don't understand it. How do I want to represent my fraction? I'm going to pick a rectangle, but don't feel forced to pick a rectangle. It's just so I can draw it consistently. How do we represent 3/4? Now, no one is really stopping me, so I'm just going to keep rambling on. When we think of a fraction or read a fraction, let's say here, reading a fraction. Like this one here in exercise 14.1. Represent the following quantities with a rectangle. 1/3. So a fraction like 1/3. Even though what you see is only 1/3, that's not the full sentence. That's not the full sentence. Attached to this are the words of a whole. Could be a whole circle, could be a whole rectangle, doesn't even matter what the shape is. I'm going to pick rectangle. Those words are always there, whether you see them or not. So if I'm a little shaky at some points, I have to remember to insert those words. My answer is never a fraction. A fraction on its own means nothing. It means nothing. It's with respect to something. It's a portion of something. Of what? Of one whole rectangle, one whole concept. It's almost like a unit. Like if I say, oh, yesterday I ran for 2. That doesn't mean anything. 2 what? 2 miles? 2 minutes? Without context, without finishing that sentence, I really don't have any meaning. It doesn't have any meaning, that number. Same with fractions. Without finishing the sentence, the third doesn't mean anything. Third of what? And if there's nothing, then luckily it's the reason there's nothing is because it's sort of there's a standard completion of that sentence of a whole. And if you see nothing, it's always there. What time will the quiz be at? Saturday, 4 p.m. All this information is in the course chat. It's a pinned message. It should be. I'm reading it right now. Test will be 4 p.m. Deadline 6:30. All the information's there. Yeah, so fraction. So now I could represent that in any way I want. I choose a rectangle for the consistency of drawing it. Whoa, not what I wanted. And then, oh, excuse me, the the numerator and denominator then tell me something about the portion that I want. The denominator tells me, split this into, whoa, that was an exceptionally straight line. Freehand, wow, look at me. That one was less. Split it into 3, the whole rectangle, and take one of those 3. And there we go. Easy. If I understand what the fraction is asking of me and telling, then we go on to a mixed number or a mixed fraction where I have a whole portion as well as a portion of another whole. But still, this of a whole, whether if I say 1 and a third, now the of a whole, it doesn't sound quite right, but it still works. I just have one whole rectangle as well as a third of a rectangle. I do this, trying to make them as identical as possible. One whole rectangle and another third. I just ran out of space. It should be on the other side. Now, really, there's a little plus in here. There's a little plus there. It's one whole rectangle with a third of a rectangle together, separately but together. Yes, so we have that. Then we have the concept of an improper fraction. And again, we're aiming to look at these intuitively. If I split my whole rectangle into thirds as well, then how many thirds do I have? I have 4 thirds. So these two are equivalent. I have the mixed fraction, mixed number, and I have the improper fraction, where the numerator is more than the denominator, then I actually have more than just a portion of a rectangle. I have a whole and a bit more. Now, improper fractions. Improper fractions are important when I go away from the intuitive understanding to efficient shortcut calculations. Sure, no place for mixed numbers. But when I am building a number sense for fractions, mixed numbers are where it's at, thinking of the whole and a portion of a whole. It depends on the purpose, it depends on my goal. Each one has a place. When our goal is intuitive understanding, number sense, mixed numbers are where we want to be. But ultimately, my numbers are going to get too big, and crossing over to something more efficient to calculate is important at some point, but not in the beginning, not for a long time. So there's some discussion there, and I don't really, in the last 6 minutes, want to go into comparing fractions right now. Any last words or thoughts? This day might have been the quietest day out of all, where the opposite should be happening. Going into fractions, we need to be much more vocal because this is not, from experience, not easy, and not getting the help you need, not saying something, not speaking up, you're just hurting yourself. I can't guess or read your mind that you have a question. So it's up to you. It's your responsibility. So hopefully tomorrow we can have more of a discussion instead of a monologue, but it is up to you. All right. Until tomorrow then.